Welcome back, my lovely students. And now we are starting chapter 5 with the first two things are called the law of sines and the law of cosines. And what these let us do is solve for different things in oblique triangles. These are triangles that do not have a right angle. Now, I do want you to remember something about how triangles are constructed. So in class, we're going to have this set up here as our default. So I have angle alpha, angle beta. Angle alpha is across from side A. Angle beta is across from side B. And angle gamma is across from side C. All right, so when we label angles, we label sides. Like this is how the correspondence works. They always go across. Another thing to note is that when you are looking at the sides of a triangle, let's say I have this C side, and I have A and B. In order for these to make a triangle, C must be smaller than A plus B. All right, so if A is 1 and B is 2, C can't be 5. If you think of a 5-inch thing and a little 1-inch and a little 2-inch trying to reach each other and they can't quite make it. So that's our first half here. The flip side is that C has to be larger than A minus B for the same reason. If I attach this B side onto the A and then the C is too small, like it's all not going to reach. It won't make a triangle. So this is true regardless of whether you have a 90-degree angle or not. So one side always has to be between the sum and the difference of the other two sides. So this is why some triangles we can just say that's not a triangle. You can kind of do it without thinking. 1, 2, and 100. Not going to be a triangle. 1, 2, 3. Also not going to be a triangle. 1 and 2, if they were trying to make legs, would collapse onto the 3 side and it would just be a line. So there are no equals here. It has to be strictly greater. The other thing is these angle and side pairs, the largest angle goes with the largest side. So in our 30, 60, 90 triangle, or just any right triangle, the 90 degrees is the largest angle. So the side across from it, which is the hypotenuse, that is labeled C in the Pythagorean theorem, a squared plus b squared equals c squared. That is the longest side in the triangle. So if you ever finish a Pythagorean theorem and you're saying one of the two legs, the not hypotenuse, is bigger than the hypotenuse, you put your numbers in the wrong spots. You need to rewind and double check. I say this because a bunch of y'all did this on the test. It was very sad for me to have to take off points when you had the right idea, but you put the number in the wrong spot. So Pythagorean theorem, C is always the hypotenuse. All right, so this is just more a like basics of triangles that you saw once upon a time, long, long ago in geometry, but you may not have made much sense of. It happens, especially with the pandemic. So I'm just putting it back here so it's a little more fresh in your mind. So let's take a look at our law of sines. So it turns out this ratio of the angle to the side, this correlation, actually shows up like this, where it's the sine of the angle over the corresponding side is equal to the sine of one of the other angles over the corresponding side, the length of the side. When you use this, you do not use all three. You use 2 of the 3. So it might be something like I have 3 of the 4 things in this. I can use it to solve for the 4th. Or it could even be the first and the last one. It doesn't matter, but you're only going to use 2 of the 3 fractions shown. And it doesn't matter if you put the sides on top or the sides on the bottom. So you have to have applicable ratios. So we'll talk about the weird case where we don't have that later. So for here, we have 2 unknown sides and angle of an angle side triangle. So when we have this AAS, or we're going to see SAS, SSS, whatever triangle, what we're talking about is what we're given. So here we're given an angle, another angle, and then the side after that. So I check my diagram here, angle, angle, side, side. Now note here, the 50 degrees is across from 10. So those two guys correspond together. So if I'm going to use my law of sines, I'll have the sine of 50 divided by 10 equals, and then whatever else I want to use. Now I've got down here the 30, so I can use that to find my unknown c. So let's go ahead and write that law of sines. So we are using sine of alpha over a equals sine of gamma over c. So alpha is 50 degrees, so sine of 50 degrees over 10 equals the sine of 30 degrees over c. So that's our first thing that we're going to solve here. So we have one fraction equals another single fraction. We can cross multiply here. I would prefer if you think about it as multiplying by the common denominator, because sometimes people will mix up when they can and can't cross multiply. It has to be a single fraction equals a single fraction. Multiplying by the common denominator will accomplish the same thing. So here our denominator is 10 times c. So we're going to multiply by 10c. And over here on the left, the 10s cancel. So I have c times the sine of 50, which is just some ugly number. And then here the c's cancel, so I have 10 times the sine of 30. And then I divide by the sine of 50. And then this is something I can crunch on the calculator to get the length of side C. Now, when you are typing this, a lot of calculators, when you type a trig function, they will open a parenthesis for you. So you need to remember to close the parenthesis before you type anything else. You also need to make sure your calculator is in degrees, because these are angles given in degrees. All right, so mine is in degrees because my radian button isn't showing in my list. So I have 10 times the sine, it opened a parenthesis, 30, close there, divided by sine, it opened a parenthesis, 50, close there. So C is 6.5270336, blah, 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 blah. Now on the test, the directions will say round to 4 decimal places. Some of you guys have been rounding to 4 significant figures instead. Math is very much behind the times, and I haven't been taking off points for it because I get it. You do enough chemistry homework, your brain defaults to sig figs because that actually makes sense. In math, we just arbitrarily pick a number of decimals and call it good. So 4 decimal places would be 2 here. So this would be 6.5270. So that is our third side. Cool. This is 6.5, blah, blah, blah. All right. Now I have my unknown angle beta and my unknown side B. And normally this could be a bit of a panic, like, what do I do? We do know two of the angles, and there's only three angles in a triangle, so we can find the third angle. So like, even though it's an initial like, what do I do? Wait, I can do something. 50 plus 30 plus beta is going to equal 180 degrees. All right, so this is 80. And we minus it over because it's being added. And we get that beta is 100 degrees. All right. So now I can relate my sine beta with B to either of the other pairs. I tend to go with the pair that we started with because the numbers you're plugging in are going to be integers or like numbers that don't have a repeating decimal. So it's easier to do the setup and solve because you won't have any decimals to try to keep track of. So that pair is our sine 50 degrees and 10. And then sine beta is sine 100 over B. All right, so 10 times B is our common denominator. The 10s cancel, and I'm left with B times the sine of 50. Over here, the B's cancel, so I'm left with 10 times the sine of 100. Last step is divide by the sine of 50. And we will get our third and final side. So I have 10 sine 100 close divided by sine of 50 close. So I have B equals 12.85575 blah, blah, blah. Whoop, we're rounding, so that actually becomes an 8. All right, so just to double check, my 30 degrees is my smallest triangle. The side length is 6.5 something. That is the smallest side length. 50 degrees goes with 10, 100 degrees goes with 12.85. Cool. We'll call that good. It's not the size of the angle is proportional to the size, but the sine of the angle is proportional to the size. So try not to mix those up. We certainly can say smallest angle, smallest side, largest angle, largest side, but how quickly it moves and changes is a different matter. All right, I'm going to cut that one and then come back.